Hello and welcome to iLearn Day 11. We're going to take a look at Pythagorean Theorem today, so we're going to work on problems 102 to 109. And so the first thing we got to know is what Pythagorean Theorem is. Pythagorean Theorem states that a squared plus b squared equals c squared. And what that really means is that if you have a triangle and the two legs that come together create a right triangle, that the square that you could build on leg A and the square that you could build on leg B would equal the area of the square on leg C. And so what that would look like for problem 102 is you have to identify the right triangle. So we're talking about right here's the right triangle. Directly across from it, that is where your C is going to be. The other two don't really necessarily matter which one's A or B. I always pick the smallest to be A just so I can be consistent. So the problem that I'm looking for again is A squared plus B squared is equal to C squared. And so 13 squared plus 14 squared is going to be equal to C squared. And so the first thing I'm going to do is go to my Desmos calculator and just type in 13 squared plus 14 squared. And so 13 squared plus 14 squared, and I'm going to get 365. And so I'm going to go back to my paper for a second. So this is all equal to 365. It's still equal to C squared. I don't want to know what C squared is. I want to know what C is. So I'm going to do the square roots of both of them so I can undo C squared. Well, the square root of C squared is simply C. And then we'll go to 365, find out what the square root of it is. So we type in square root 365. We get 19.10. We're going to round to the nearest tenth. So we're going to do 19.1. So this is 19.1. Again, we rounded to the nearest tenth. Notice how 19.1, C is always the largest side. So if for some reason you're working this out and you get an answer that is less than A or B, then you've made a mistake somewhere. Problem 103, again, the one diagonal from the right angle is C, so this is C. I always name the smallest one A and the biggest one B. So 3 squared plus 10 squared is equal to C squared. And you'll go through and work this out. You can type this into a calculator, but I happen to know that this is 109. It's equal to C squared. And again, I want to find the square root. And so the square root of C squared is still C. The square root of 109 is 10.44. Again, I'm going to round to the nearest tenth. So since the second 4 is less than 5, we're going to leave it the same. So 10.4. And that is your answer. Looking at problem 104, again, the one across from the right angle is C. This one looks like it's the smallest one. This one looks like it's bigger. So we're going to do A squared plus 11 squared is equal to 12 squared. There's a couple different ways you can do this problem. You can rearrange it now, or you can wait till the end. I'm going to wait till the end. A squared, 11 squared is 121. 12 squared is 144. Just like with the equations, I want to move so that I get the variable by itself. I'm going to subtract 121 from both sides. A squared is going to be equal to, these cancel out, 144 minus 121 is 23. And if you're not sure, you can always check it with the calculator. 144 minus 121 is 23. We want to know what the square root of that is. So the square root of 23 is 4.79. Again, we're going to round to the nearest tenth because the second number from the decimal is a 9. We're going to round it up to 4.8. So this is going to be 4.8. And again, it's going to be equal to a. Square root of a squared, square root of 23. And then we're going to look at problem 105. I'm going to notice that, again, this one is C. This seems small to me, so A and B. So 2 squared plus B squared is equal to 8 squared. And so, again, I'm going to work it out. 4 plus B squared is equal to 64. I want B by itself, so I'm going to subtract 4 from both sides. These cancel out. B squared drops down. It's equal to 60. And then I want to find the square root. The square root of B squared is B. The square root of 60 is 7.74. Because the 4 is less than 5, we're going to leave it the same, so it's going to stay 7.7. And that is the answer for B. Looking at problem 106, it says Tom is looking at a map of the theme park. The map is laid out in a coordinate system. Tom is located at 2, 3. So let's put Tom on the map. He's at 2, 3. Right here is where Tom is. We'll label him with the letter T. The roller coaster is at 7, 8. So 7, 8 is right here. We'll label him with an R. The water ride is located at 9, 1. We'll label that one with a W. It says, is Tom closer to the roller coaster or the water ride? Use words, numbers, or symbols to justify your reasoning. The first thing you're going to do is you're going to create some right triangles so that you can figure out the distance. So I'm going to connect Tom to the roller coaster. And then I'm going to create this right triangle where this is C. And so I can figure out the distance of C by saying 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so I know that A squared plus B squared equals C squared. So 5 squared plus 5 squared is equal to C squared. And this will tell me the distance from the roller coaster to Tom. And so 25 and 25 make 50. Again, you can use a calculator. Is C squared. I'm going to find the square root. So the square root of 50 is 7.07. So 7.1 we'll call it. 7.1 is equal to C. And so this is the distance from the roller coaster to Tom. And we'll just keep that there. And then we want to do the same thing from Tom to the water slide. We're going to create a right triangle so that we can figure it out. We've got 2, 1, 2, 3, 4, 5, 6, 7. So this is 7. So we should do the problem 2 squared plus 7 squared is equal to C squared. And so we're going to work this out. We've got 4 and 49. That's going to become 53 is equal to C squared. Now you can see pretty quickly that without even finishing this problem, that 53 is bigger than 50. So that means that the water slide is further away. But we'll go ahead and finish the problem. We're going to do the square root of both of those. We'll get C. The square root of 53 is 7.28. We'll round that to 7.3. 7.3. And so looking at that, we can see that 7.3 is greater than 7.1. So Tom Tom is closer to the roller coaster and then you can put because (7.1) is less than 7.3. Moving on to problems 107. It says a soccer field is a rectangle 90 meters wide and 120 meters long. The coach asks players to run from one corner to the other corner diagonally across the field. How far do the players run? I like to draw pictures when I do these types of problems. So we're talking about a soccer field, which is a rectangle. And so this is 90, this is 120, and the coach is asking them to run from one corner to the other corner. And so they're running from, we want to find this, and we can see that this is a right triangle, so across from it is going to be C. So the problem I'm going to look for is 90 squared plus 120 squared is equal to C squared. And so then we'll work that out. We can go to our calculator. We can type in 90 squared plus 120 squared is equal to 22,500. We're going to find the square root of that eventually, so we'll just go ahead and type that in so we don't have to come back, is 150. So we got 22,500 is equal to C squared. We're going to do the square root. We find out that 150 is equal to C. And so this is your answer. However, it's probably going to want your answer to say 150 meters. The bottom of the ladder must be placed 3 feet from the wall. The ladder is 12 feet long. How far above the ground does the ladder touch the wall? So we've got this wall that's standing here. We have a ladder that's leaning up against the wall. And then we have that it is placed on the ground. And what we know for sure is that the distance from the wall to the ladder is 3 feet. The ladder itself is 12 feet. And so keeping with that, we can see that the right angle is going to be right here. I know that because that's where it kind of looks like an L. And so we're going to label this one B because this one's C, and the smaller one seems to be A for me. So 3 squared plus B squared is equal to 12 squared. Again, you can work this out. 9 plus B squared is equal to 144. I'm going to subtract 9 from both sides. B squared is equal to 135. Again, you can use a calculator if you're not real strong on that. So 144 minus 9, 135, and then we're going to do the square root of 135. So the square root of 135 is 11.61. We're going to round that to 11.6. So again, square root of this, B is equal to 11.6. And since everything's measured in feet, it should be labeled as feet as well. And this is your final answer. Looking at the next problem, it says Jill's front door is 42 inches wide and 84 inches tall. She purchased a circular table that is 96 inches in diameter. And so will the table fit through the door? And so we've got this circular table, and the diameter from one side to the other is 96 inches. But we want to see if it's going to fit through a rectangular door that is 42 by 84. So we definitely know that taking the table and standing it up straight up and down is not going to fit through the door because it's 96 inches. So it's not going to fit through the door straight up and down. So what we're going to have to do is see if the table will fit through diagonally. And so to do that, what we have to do is we have to do 42 squared plus 84 squared is going to be equal to c squared. And so we're going to start there. So 42 squared plus 84 squared is 8820. So 8820 is equal to c squared. And then we'll do the square root of 8820. So square root of 8820. Oh, make sure you just get 1. 8820. And then you get 93.91. And so C is 93.91. So this is 93.9 is equal to c squared. And so then we got to compare the 96 to this 93.9. And so if we need the doorway to be bigger than the table, so we need whatever c is to be equal to or greater than 96. So 93.9 is less than 96. So that means the table will not fit through the door. The table will not fit through the door. And this completes today's iLearn review videos. Beginning tomorrow, we'll start taking a look at volume of cones, prisms, and pyramids, cylinders, and spheres. And then we'll also take a look at what the surface area or volume of a sphere is based on a baseball. So we'll look at problems from 110 all the way to problems 122.